Welcome to the course, and now I am going to start with the advances in abrasive flow finishing process. Till now you have seen what is abrasive flow finishing process and other things. Now we are going into a few of advances that the researchers have done in this area. So the overview of the lecture. So we will go ahead with introduction to various advancements. What are the advancements? There are three advancements that I am talking about majorly, and the first one is drill bit guided abrasive flow finishing process. Then second one is centrifugal force assisted abrasive flow machining process, bar finishing process, because the author, whenever you are going through the literature or whenever you are going through the papers that I am talking about the concept here. So the paper says a centrifugal force assisted abrasive flow machining process. However, as you know that nowadays abrasive flow finishing process is for the finishing process. So the machining part has been partially converted by some of the researchers into finishing. Some of the authors still follow machining only. That means that abrasive flow machining, some of the people will follow abrasive flow finishing. So both are same. That is why I have written here abrasive flow machining bar finishing process. Okay. So then the spiral polishing process and advantages and disadvantages of these advancements. Then we will see the summary of the particular class. So the advancements, the first advancement is drill bit guided abrasive flow finishing process, and I will come each and everything in a elaborative way in the upcoming slides. The second one is centrifugal force assisted abrasive flow finishing process or the machining process, and the third one is spiral polishing. But spiral polishing, there is no reciprocation motion such as drill bit guided and centrifugal force assisted, but we are talking this as one of the advancements because here silicone based and modified silicone based medium is used, that is one type of polymer based medium is used. Since our subject is polymer assisted abrasive finishing processes, so silicone polymer is also subset of that one. So the medium that is shown here is a silicone based medium blended with abrasive particles and some of the rheological additives. That is why we are taking up this as also as one of the advancements. The first one that we are going to see is drill bit guided abrasive flow finishing process, and the advancements in this one you can see here. The only difference that you can see in the drill bit guided abrasive flow finishing process and the abrasive flow finishing process is fixturing. That means this is the lower medium cylinder and this is the upper medium cylinder, and this is the fixture region where you are going to place your drill bit and other workpiece materials and other things. Same thing, the drill bit you can see here, okay, and this complete region whatever you are seeing here you can see here practically. Okay. So I am having a medium here and you are having two locking plates that you have seen in the abrasive flow machining process. You will need to lock the workpieces. Okay. So this locking system has been changed, and you can see here you have two locking plates. This is locking plate, okay, where your drill bit, two edges, this edge and these edges are fixed to the hole that is provided in a locking plate. Okay. So I mean to say is I have one locking plate here and another locking plate here. In between there is a hole and there is a openings, all the kidney shape openings are there, this one. So here you will fix your drill bit. Okay. Okay. You can vary your drill bit diameter in the current scenario and you can check the finishing. The main purpose of this one is to reduce the medium that is going at the center. That means that ineffective abrasive particles are to be made active in the drill bit guided abrasive flow finishing process. How? That we will see in the next slides. And what you have to see here is you have two kidney shaped openings are there at the bottom and at the top, through which medium will come. So that means that whenever the medium is coming out from the finishing region to the upper medium cylinder, whenever you are pushing from the bottom cylinder, so this will become a split one. So this split will come into the upper medium cylinder because the medium is a self deforming medium, and it is freely flowing medium. So the mixing and intermixing of the medium will take place, and the abrasives, the new abrasives will come into picture. So the difference between abrasive flow finishing process and drill bit guided abrasive flow finishing process, the major difference is tooling. As I said, the tooling that you have seen till now, that the drill bit will be there, and drill bit will be accompanied by the two locking plates with kidney type of openings. In abrasive flow machine, the circular plate allows the medium to flow as a cylindrical slug. Okay. But whereas in drill bit guided abrasive flow finishing process, you have a twin slot on the fixture and it assists aligning the drill bit along the fixture plate. The main function of this one is it will align the drill bit, at the same time it will also split the medium. Okay. The abrasive intermixing or reshuffling in abrasive flow finishing process is purely depend on medium self deformability only. Okay. So in drill bit guided abrasive flow finishing process, the abrasive mixing depend not only on the self deformability but also on the pressure of the drill bit that is there in the finishing region. Okay. If the finishing region drill bit is there, what will happen? The medium has to split into two halves because the drill bit has two flutes. Normally even flutes will be there in any type of conventional drill bits. Okay. So it can go in a two flutes at the same time. The medium far away from the drill bit may go as a slug, but the abrasive particles which are there in the near the drill bit can be pressurized towards the active region, that we will see. The abrasive particles in abrasive flow finishing process is the shortest contact length, that is a straight line. Normally extrusion pressure is there, then you will have a shortest path, but in the shortest path, that means that number of peaks encountered by the abrasive particle is minimum. Assume that you have a helical path, that means if the height is same and you have a helical path in that one, so you will have a more distance that the abrasive particle is covering. For that purpose, there are three types of flows that you will see in the upcoming slides, and intermixing of the medium will also takes place so that the new abrasive particles will come. So this will enhance the finishing ability of the process. So advancement, in order to provide random motion to the abrasives in the medium, it causes the frequent reshuffling of the medium, that is drill bit causes the frequent reshuffling because the curvature of the flute changing point to point. That's why the abrasive particles also will vary in the finishing region. Okay. And the medium is pushed through the helical flute drill which placed in the finishing region. The idea behind the drill bit guided abrasive flow finishing process is same as earlier, to increase the material removal rate and finishing rate. That means that the amount of change in roughness that you are getting per unit time. This process almost component similar to abrasive flow finishing process except the tooling. So the setup was designed and fabricated normally at IIT Kanpur. So I am very thankful for the IIT Kanpur. So the tooling of drill bit guided abrasive flow finishing setup at a lower and upper medium cylinders, and you can see here the same picture again it is there. So these are the various elements are there. What you have to observe is how the medium is entering, how the medium is exiting. Okay. So this is the plate here and this is the plate. Again here the same plates are there, two plates are there. Okay, the two plates, whenever you are pushing from this side medium, so this will enter through this kidney shaped structures and compresses because of the drill bit that is the presence in the finishing region. Because of this exit in a two-way, so medium is self deformability, so the new cutting edges will come because this will have a intermixing in the medium cylinders. Okay, that you can see here how the medium slug divides into two halves. So the medium slug which is coming from here, the section AA, if you see the section AA, so the medium slug is coming out, and here the drill bit is holding at this position in the top view, and this medium slug will intermix and new abrasive particles will come. But whereas in abrasive flow finishing process, it is a cylindrical slug. So the complete intermixing of the medium is completely depend on self deformability characteristics of the medium, that is polymer rheological abrasive medium only. Here the drill bit also helping in the intermixing of abrasive particle. If there is a intermixing of abrasive particles, what will happen is the new abrasive particles may come into the finishing region and the weared out particles may go inside, or it may have new cutting edges of the existing abrasive particles will come into picture for the finishing action. That is the beauty about the drill bit guided abrasive flow finishing process. Okay, various medium motions, if you see in the picture, so because of the drill bit we have various motions. The first motion that you can see here is because of the flute. This is the flute, there is a motion along the flute, and because of the reciprocation, the abrasive particles away from the drill bit may reciprocate. That is the second one. The third one is scooping flow, because you know always the drill bit will have certain cutting edge slightly bigger than the flute. So it will come like a ice cream scooping. So all these motions I will explain, and these are the three motions combinedly work and reshuffling of abrasive particles, and pressure will be generated on the medium, so that this pressure will be carried and exerted on the finishing surface. The first motion that you can see here is the helical motion, that is because of the flute. Two halves of the medium either side of the drill bit have the three possibles. Okay, the first possibility is flow along the flute, because the flute will have cavity, big cavity. So medium tries to go wherever the space is there. Means that the flute having a maximum space, so it will occupy, and the medium flow will be faster at the center compared to at the finishing region. Because of that, what will happen is medium tries to flow through the flute. Okay, that is the inner region of the medium slug tries to flow along the path of the flute. Because of its self deformability and self adaptability will takes place. It will adapt all the motion along with the flute. The second one is reciprocating axial motion. The medium near to the workpiece, because this is slightly away from the flute and away from the drill bit in that circumstances. At the same time, drill bit is a cylindrical surface. If you see, my drill bit is a cylindrical surface and my workpiece is like this. Okay, in that circumstances, if you see the top view, it will be like this. So only this region, not only this region, it also will have these regions also will flow in a reciprocating way. Okay, that means that it tries to reciprocate axially, because the influence of the drill bit from its surface towards the workpiece surface will gradually reduce. So if the influence of this one reduces, what will happen? The reciprocation motion will be dominating. That means that even though the reciprocation is there, but because of this fluid nature, because of the obstruction, what will happen? The abrasive particles may move into that region and helps the reciprocation. And we will see how whether the surface is only by the virtue of reciprocation or fluids also play a major role in this process, that we will see whenever we are going to study about scanning electron micrographs, that is the surface morphology of the surface. Whenever we see, we can understand it is purely because of the reciprocation or any other motions also coming into picture. How do you define or how do you determine if it is a purely reciprocation motion? Then you will have the straight lines. Assume that I have a grinding surface like this and I have the grinding lay, that is predominant surface direction. So, if I am moving my abrasive particles like this, what will happen? The final finishing lines or the surface lay in the abrasive flow finishing process will be like this. But if we have a fluid and if there is a direction it is giving, so in that circumstances it may not be exactly as a vertical, it may go any certain inclinations. So, if we are going to get certain inclinations on the surface morphology, then we can determine that it is not only by the virtue of the reciprocation, but also there is a domination by the fluid or the inclinations that is developed by the drill bit. So, the flow in the finishing region, the third flow is the scooping flow. Familiar to the ice creams, many people will see in the ice cream parlors, so scooping will be done. So, they will just, if you want, okay, I want the strawberry, I want the vanilla, I want the butterscotch, so otherwise I want the mixed. So, you do the scooping. How the scooping? You will have a cup of thing and you will have a semi-solid ice cream, so you can get the scoop. Since the fluid depth is gradually decreasing along its width, the medium that flows across the fluid path try to scoop out from the fluid edge. That means that you will have a fluid edge, this fluid edge is big and you have a cavity also. So, my medium is going like this and comes like this because of the scooping action. Okay. So, the abrasives in the scooping flow are inclined to at an angle that is called alpha, that we have named, to the reciprocating path of the scooping medium flows across the axial moving medium at an angle alpha. Okay. So, this is the scooping flow. So, that means that the scooping flow causes intermixing of the abrasives in the intermediate region and exterior regions of abrasive slug. That means it shows that if there is a scooping flow, if scooping is there like this and abrasive particles are moving like this. Okay. So, if this moves like this, what is the beauty about this particular process is the self deformability medium will mix and the velocity that is carrying will move like this and it will flow towards the finishing region. That is the beauty. And I know my finishing region is this. This is my finishing region. Okay. My scooping flow direction is like this and it will move along this direction, and because of the self deformability, the abrasive particles, because of the self deformability, the abrasive particles in the scooping flow and along the direction of the flow, this will make the active abrasive particles. Active abrasive particles means those particles which are there in the finishing region will become the active abrasive particles. The scooping flow of the medium, at the same time the flow along the fluid makes the active abrasive particles, that is those particles which are there in the finishing region become more dynamic. That means that the abrasive particles which are there in the finishing region may get some dynamic motion, and the new abrasive particles or this dynamic motion causes the new cutting edges at least. So, that improves the finishing performance. So, if it is not going to change, but the medium velocity will be high compared to the abrasive velocity, assume in that circumstances my medium, that means the polymer chains will move. If the polymer chains will move, what will happen? The abrasive particles at least may have some rotation or some random motion, because of which the new cutting edge may come into picture, and this can improve the finishing ability of the abrasive process. Now we will see, we have three motions. One is a reciprocation motion, and the second one is the along the fluid direction motion, and the third one is scooping flow. This green one is a scooping flow. Okay. So, the reciprocation shows the red color one, and the black color arrow shows the flow along the direction of the fluid, and the green arrows shows the scooping flow. Because of these three, what is going to happen is the medium will get some random motion. At the same time, the medium will be always continuous, always in the dynamic condition, and the abrasive particles in the active finishing region will get reshuffled. If it is reshuffled, that will be the best solution. If the reshuffling is done, that means that new abrasive particles will go. If there is not much reshuffling is there, in that circumstances, at least the new cutting edges, because of the motion of the abrasive particle, new cutting edges will come into picture. Okay, that you can see here. The abrasive particles which are red color are supposed to be reciprocating in nature, and the black ones are moving along the path. You can see here. You may not exactly differentiate the green ones here. So, the green ones will have the scooping flow because of the blue ones. So, the blue ones also there, these blue ones will have the scooping motion assume. In that circumstances, what is happening is completely randomization or the dynamic motion is there in the finishing region. Because of this, what will happen? You can assume that there is a medium self deformability along with scooping flow along the fluid, and reciprocation causes the medium enormous or increases the self deformation, and the new abrasive particles will come into picture. Because of this, the finishing action will be improved and the finishing rate, because in the abrasive flow finishing process, if the self deformation is the only cause to reshuffle the abrasive particles. Here the reshuffling is done by motion, reshuffling is done by the scooping flow as well as flow through the fluid also. So, it increases the cutting edges, it increases the reshuffling, because of which the finishing rate can improve, because the new cutting edges will come, new abrasive particles will come. Even though the number of cycles is same, the finishing action will be improved. So, how the MRR and other things will improve? Due to the combination of different flows, the workpiece abrasive contact length no longer a straight line, because the helical is there, scooping is there, and other things. Rather, it become non-linear basically. So, hence the number of peaks that can be sheared will obviously increase, because if the distance or the contact length of the abrasive particles with respect to surface peaks will increase. So, if it is increases, and the abrasive particles also gain certain additional velocities and additional radial force. Because of this, what will happen? The material removal will increase, that means that number of peaks shearing will improve, that means surface roughness will decrease, that means change in surface roughness will increase. So, the people who are watching should understand some of the graphs I am talking about RA, that means CLA, that is nothing but central line average value, that you have already studied, and delta RA means change in RA. Normally RA should be less. If it is less, that means that your surface roughness is less. That means your surface finish is good. Okay. So, delta RA is RA initial minus RA final. Okay. So, that means that if it is as maximum as possible, that means that my surface improvement is maximum. So, you require here maximum and percentage delta RA. That means that the percentage RAI minus RAF by RAI into 100. So, that means that this also I require maximum. Okay. This please make sure that whenever some of the graphs, because these are the things that I have taken from the research papers. So, some people they have reported in terms of RA, some people they have reported in terms of delta RA, some people or the researchers represented their graphs in percentage delta RA. Okay. So, whenever you have delta, that means that change, you always require maximum. If only RA you are talking about, then you require minimum. Okay. As minimum as possible, the surface roughness decreases, means you will get a better smooth surface. Okay. So, this is about the clarification on the surface roughness and other things. So, you should be careful whenever you see the graphs. Anyhow, I will remind you that I am talking about delta RA, change in RA, percentage change in RA or average surface and other things. Now, we come back to the drill bit guided abrasive flow finishing process. The combination of all these flows along with the self deformability leads to intermixing of abrasive particles in the finishing region and random motion of the abrasive particles. When the medium exits from the finishing region, it enters into the medium cylinder through the half walls. That means that, as I said, two kidney shapes through it will enter and mixing will also takes place there, not only in the finishing region. This also include intermixing and increasing of the probability of participation of new abrasive particles in the finishing that I have already discussed, and the viscoelastic nature of the medium further enhances the intermixing, because the viscoelasticity, as I said, that whenever you have a shear force in this direction, axial motion will be in the same direction, radial motion will be perpendicular to it. That also will have certain effect on the intermixing. Due to the presence of drill bit in the finishing region, or the finishing region, pressure induced on the abrasive particles, and this will indirectly work on the workpiece from the point of radial force. Okay. So, the radial force is high, obviously your indentation will improve. So, you can see here in the abrasive flow finishing process and drill bit guided abrasive flow finishing process. In abrasive flow finishing process, you normally see the minimum traverse length, because you are reciprocating. So, most of the time it will be the shortest distance. Okay. So, in terms of drill bit guided abrasive flow finishing process, okay, this is the experiment is stopped at certain number of cycles to understand the direction of the path. Okay. So, it is an inclined path. If it is an inclined path, normally the distance that is covered will be enhanced, and at the same time these are SEM images, that is scanning electron microscopy images, that you are going to see in a particular very small region, that you can see here what is the distance. This much distance is 50 microns, and some of the students may not know how to measure and other things in a scanning electron microscopy. Assume that if you are a bachelor student, so you may get some doubt what is a scanning electron microscopy, how it works and other things. That is a different story, but the thing is that from the picture you can understand what is the area that can cover or something. Normally if you see this much distance is 50 microns. So, obviously approximately I can say this you can divide into 3 halves or something, 350 microns. So, maximum that it covered is 150 microns by 150 microns area. Okay. In that area, even though it is a curved surface, you are taking a very minute area, you will see as a inclined surface only. Okay. Does not matter. So, the inference that you can get from this one is our scooping flow and the inclination flow along the flute helped the abrasive particles which are there in the finishing region to move in the inclined direction. So, that the shearing length will increase. If the shearing length increases, what will happen? The finishing will improve. If the shearing length per unit time, because your reciprocation is same, so per unit time the number of peaks it is cutting or shearing is high compared to the straight line path. That is why in drill bit guided abrasive flow finishing process, your RA will be slightly less compared to abrasive flow finishing, but do not go by this particular image because this is taken after few cycles only. Okay. So, if you take after some time, what will happen? It can improve. That you can see here the performance comparison of this process will with respect to abrasive flow finishing process. So, as the number of cycles versus material removal, if the number of cycles are going to increase, obviously the abrasive particles that are cutting or the shearing the surface peaks will increase. Number of times abrasive particles will cut increases, obviously number of peak shearing also increases. So, the material removal will gradually increase. However, if you see the change in RA, you have to note, just now I told it is mentioned in the terms of percentage change in RA. That means that you need as maximum as possible, because you are talking about percentage delta RA is nothing but RA initial minus RA final by RA initial, this multiplied by 100. Okay. So, in this way you just consider. So, if you want good surface, that means that your value of percentage delta RA should be high value. So, you can clearly see that is there in drill bit guided abrasive flow finishing process because of whatever the physics that I have explained, and that is confirmed by the surface morphology scanning electron microscopy images because of the fluid direction motion, because of the scooping motion and the reciprocation motion. The active abrasive particles will reshuffle and reshuffle and reshuffle, and intermixing of the medium will also takes place. Because of that, the new cutting edges will encounter the surface peaks and finishing will improve. So, you can see the drill diameter. If the drill diameter is increased from 8 mm to 10 mm to 12 mm, normally the size of the workpiece that we are going to finish is approximately 25 mm. So, half of this is covered if you are going with 12 or 12.5 or something. As you can see here, if I am using 8, 10 and 12 and other things, but it will be 9, 11 and 13. Okay. So, what I mean to say is that if I am increasing, does not matter whatever the size of the drill bit that I am taking, whether it is 9, 11, 13. Okay. So, if my workpiece diameter, internal diameter what I am finishing is 25 or 26, that means that if I am using 13 diameter, so that means that half of the thing I am covering. So, very less space is there for the medium. So, that means that radial forces will be enormous. Not only the intermixing will take place, radial force also play a major role, because of which what will happen, the indentation on the surface will be high and shearing is obviously is there because of the your scooping flow, reciprocation flow as well as inclined flow and other things. So, the material removal also will increase as you increase the drill bit diameter. If you see the weight percentage of oil, oil means plasticizer. Okay. So you know in the abrasive flow finishing process what is the function of plasticizer and other things. Plasticizers are low molecular weight materials and polymers are high molecular weight materials. Whenever you try to blend these, what will happen? Low molecular weight materials will go and sit between two polymer molecular chains and try to move apart. So the flexibility of the medium increases. If you go on increase the oil content or the plasticizer content, what will happen? The polymer molecular chains will gradually increase the distance and it will become a liquid or too low viscous. Okay, your polymer has certain viscosity. Whenever you add abrasive particles, the viscosity will goes up. If you start adding the plasticizers, if then what is happening here is the intermolecular polymer distance will increase and the viscosity gradually decreases. If the viscosity decreases, what will happen? The medium flow along the reciprocation will be dominating and radial force will be very less. As you have seen, there is a radial component, that is Fr, and axial component. Your Fr is responsible because of the elastic nature and Fa is responsible because of the viscous nature. If your elastic component is less, that means that radial indentation will be less. That means radial force is less. If the radial force is less, what will happen? The interaction with respect to the surface peak will reduce. That is the problem. Okay. So if your plasticizer increases, your elastic component will reduce. Why the elastic component will reduce? Because your polymer molecular chains are far away. So they are not cohesive enough to support the abrasive particles to push radially. That is the problem. That's why the viscosity of the medium goes low in a qualitative statement. If the viscosity is low, that means that your finishing ability gradually decreases. That you can see here. Because of that, material removal also will fall down and your change in roughness or delta change in roughness also fall down. So you need to choose certain value of a viscosity where you can do the good. For that purpose, normally you have to choose approximately 10 or in this region so that you can get better results. You can see here, this is the grind surface. Normally this is the grinded surface, or some people they say ground surface, because the grinding motion is like this. If your workpiece is like this and your grinding is like this, okay, so because of which you got the straight lines. Okay, so what is happening here is after few number of cycles, as I said, that you will get, because of the scooping flow along flute and reciprocating. Okay, the three motions, and you can see at the end. Okay, as you increase number of cycles and you have to optimize all the things, you have to optimize the drill bit diameter, you have to optimize the number of cycles, you have to optimize the medium composition and other things. Whenever you get all good, you will get the better surface finish. That and the surface finish that you will get at lesser time compared to your abrasive flow finishing process. And what is the inference that it will give is, if you have a drill bit or another obstruction is there, so you can change the path of the abrasive. Okay, just you remember this one, because we come across some of the advancements like rotational abrasive flow finishing process, and there your workpiece is rotated, not the medium. Okay, so now we move on to the another advancement, that is called centrifugal force assisted abrasive flow finishing process or abrasive flow machining process. So one thing you have to understand, so this is taken from the papers from IIT Roorkee, Professor H.S. Shan ji and Pradeep Kumar ji and Ravindra Walia ji. So the papers, if you are referring, it is always given centrifugal force assisted abrasive flow machining. As I said, it is the same, abrasive flow machining, abrasive flow finishing, both are the same. Okay, so that's why I have written abrasive flow machining bar finishing process. Okay. Introduction to centrifugal force assisted abrasive flow finishing process. Just you have to get one correction here, that is called CFA. So, centrifugal force assisted abrasive flow finishing process. Okay. So, introduction to centrifugal force assisted abrasive flow finishing process. It is an advancement of abrasive flow finishing process where centrifugal force guided rod will be there. So, they are going to place a rod with different shapes and rotates at different speeds. Okay. So, in that circumstances, how the finishing will improve, whether the finishing improves or don't improves, what the authors have done, we will see. It increases the pressure on the abrasive in the medium, and while it contacts the surface during the processing, the pressure increase provides the centrifugal force generating rod will be there, and rotation mechanism is developed, and it helps the medium simultaneously to rotate at speeds and along with the axially pushing. So, you know abrasive flow finishing process where the only reciprocation is there. Okay. Along with it, what the researchers they have done is, in the finishing region, instead of the drill bit that you have seen in the drill bit guided abrasive flow finishing process, they have used different shapes like spline, triangular, rectangular, square type of rods they have used. Okay. Rod means don't think that it is a big rod or something. If your workpiece is, assume that it is 40 mm or 50 mm, the rod will be like 10 mm or below 10 mm. Okay. So, centrifugal forces in abrasive flow finishing process, workpiece is finished relatively fewer number of processes compared to abrasive flow finishing process. That means that the authors or the researchers, Professor Walia and group, they have demonstrated that the number of cycles required in centrifugal force assisted abrasive flow finishing process is less compared to conventional abrasive flow finishing process. This is the setup that you can see here. So, the setup may not be that much easy to understand, but however, I will explain you in the upcoming slides. But only thing that you have to understand here is, this is the finishing region where you are seeing the medium, and the finishing is occurring in the this square. So, in this square you have a cylindrical workpiece, assume. So, this cylindrical workpiece is at the center of the cylindrical workpiece, you have a rod basically. Okay. And this rod will be rotated. External gearing system is there, that you will see in the upcoming slides. This is provided reciprocation. This rod is rotated along with the medium reciprocation. Medium will be reciprocated. Okay. Now, hope you understand that medium is reciprocated, and with the help of external gear system, there will be a small rod will be there, and it is rotated. What will happen? Because of this rod rotation, centrifugal action on the abrasive particle will be there, and this abrasive particle will be pushed towards the surface. Assume that this is my abrasive particle, this will be pushed towards the surface, and you can increase that. So, the finishing rate will improve. Various parameters, normally people say that Ishikawa cause and effect diagram or fishbone diagram. The medium is one of the most important. Machine and workpiece are the things. In the machine, basically here the change in the advancements, whether you talk about centrifugal force assisted abrasive flow finishing process, or whether you talk about a drill bit guided abrasive flow finishing process, or spiral polishing, or any other thing, the most important change that they have done is tooling. Okay. Tooling. Some of the papers they also say about fixturing. Okay. In abrasive flow finishing process, this means same. So some people they may say tooling, some people they may say fixturing, but in general there may be a slight difference is there, but pertaining to the abrasive flow finishing process and its advancements, this is approximately same. So the medium, the shape of abrasive particle, size of the abrasive particle, viscosity and types of abrasive particle, abrasive concentration, temperature that you are using. If you are using at room temperature, you can neglect the temperature. So there won't be much change. But during the operation, because here also centrifugal force is there and reciprocation is also there, because of which there will be always some tendency to generate the temperature, or the temperature will generate during the process, because of which viscosity may go down. The second is the machine, where you talk about number of cycles, medium flow rate. Medium flow rate is a function of extrusion pressure, and already extrusion pressure is here. Rotational speed of the centrifugal rod and shape of the centrifugal rod. So most importantly, you can see about rotational speed, and we will see about shape of the rod. This is the only variation that deviates this particular process from the conventional abrasive flow finishing process, because workpiece and other things are approximately same. What is the length, geometry, whether it is a board or whether it is a reamed, whether it is a drilled one or whether it is a cylindrical grinding one or something that you can do, whether the material is a ductile or brittle, these are constants. The same thing goes in the abrasive flow finishing process also, but most importantly what is new particular to centrifugal force assisted abrasive flow finishing process is that rotational speed of the centrifugal rod and shapes. What are the shapes? Now you can see the fixture or the tooling for centrifugal force assisted abrasive flow finishing process. The fixture holds the workpiece which is in place between the medium cylinder and create the artificial dead zone and increases the pressure necessary to extrude. Okay. So the fixture is made three parts, a workpiece rotating attachment. Normally these are the nylon fixtures are designed, and there is a gear system, and what you have to observe is here you have a rotating attachment. Okay. This rotating attachment will go and sit here. Okay. So because of the gear system that is externally protruded, this one and this one, this gear system will rotate. Okay. So because of this rotation, your centrifugal rod which is here will rotate. Okay. So that's how the rotational motion is imparted to the medium via centrifugal rod. Okay. Experimentation indigenously developed. The authors have developed indigenously this fixture that holds the workpiece and the centrifugal force assisted rod. The fixture is made in three segments that we have seen: workpiece together along with the centrifugal rod, and you have the gearing system and other things. The gear rotating attachment was designed to give necessary rotary motion and torque to the centrifugal rod, and the fabricated and positioned close proximity to the workpiece fixture. Okay. This is done, and the shape of the rod. You can see here, this is a nylon fixture that is what you have seen in the previous slide also. So this is the rod, centrifugal force assisted rod, and which is get assistance from the other two gears, gear 1 and gear 2. This will help to rotate at different speeds. Okay. So as I said, the rotary motion will be provided from here, rotational motion to the CFG rod will be provided from here, and the rod shapes also considered. These are the two new things. Okay. Rod shape is one new thing in this one, compared to abrasive flow finishing process. And second new thing that is there is rotational speed that they are imparting using centrifugal rod. Okay. The normal shapes that you can see is a triangular shape, spline, okay, and you can see a square and the rectangle. These are the four shapes that are mentioned here, and you can see the edges. The edges, there are arrows. These arrows shows how this will hit the abrasive particles, and these abrasive particles will push towards the workpiece. This is the assume that workpiece, and the abrasive particles will move in this direction and take part along with the reciprocation motion. That means that already reciprocation motion is there and additional centrifugal force is imparting to the abrasive particle. So, the finishing will improve. The material and surface area and the length of different shapes of centrifugal rods were maintained constant. This is maintained, that means that the length of the rod is constant, however, the shapes are different. The medium formulation used in the study is a silicon based polymer, and hydrocarbon gel and abrasive grains are used. After processing the workpiece for pre-decided number of cycles, that means that the number of cycles are decided whether you want 100 cycles or 50 cycles or 10 cycles, that is did, and the surface roughness and weight loss, that means that the authors are going to measure the surface roughness value and the material removal. The average surface roughness was estimated from 20 measurements, okay, taken at different locations on the workpiece surface. One thing you have to observe here, what is the thing is that many people may not be knowing. Assume that this is my workpiece surface, it is a cuboidal surface, assume, okay. So, this is initial surface roughness and final surface roughness. How we have to measure? Since the abrasive processes, especially like three-dimensional tribological processes, that means that where the abrasive particle will have 3D abrasion, that means that abrasive particle can rotate about its own axis, is completely random. Cutting edges are random. In abrasive processes, cutting edges are random. The abrasive processes such as lapping, such as abrasive flow finishing processes, where abrasive get free flow, can rotate about its own axis, and on top of it you have drill bit is there where the different flows are there, scooping flow, fluid flow and other things. Centrifugal rod is there in CFA AFM. So, what will happen? There is a centrifugal motion is imparted along with the reciprocation. So, the system is completely random, that is what I want to say. The abrasive particles are random. In that circumstances, the surface roughness that you are going to get on this particular surface is random. That is why the author rightly pointed out that the surface roughness has to be measured at different levels or different zones of the finishing zone before and after. How? Assume that I want to do at 5 places. So, this is the one place that I want to do, second place, third place, fourth place, fifth place, assume that sixth place I can do, seventh place I can do. I can mark it, okay, and after finishing also we can measure at the same location, and initial we have measured, final also same, approximately same location you can also measure, and you can calculate the change in RA or how much final surface roughness is achieved or percentage change in RA and other things. Okay. Make sure that in abrasive finishing processes, if you are not maintaining the locations also, it is okay. Sometimes how the people will do is they just put the marker, pen marker. So, like what I put on the surface, and due to finishing action these marks also will goes off. For that purpose, people what they will do is they will do some indentation using the punch on the other side, which is not required for us. You can do some punching there and you can measure also. So same location at the central line, assume that I want to measure at the central line or any other line, you can measure. Only thing that you have to is you have to measure as much locations as possible, so that the average value will give you good idea. You should not measure at one location, wow, I achieved a nano surface finish. That is not the right way. So you should always measure at a different locations. If possible, same locations before and after. If not possible, as many as possible locations you measure, and you take the average value that you are going to report into the research papers will have good value. Okay, that means that you are doing right thing. And you can also plot error bars, so that your research paper can be made in a good way, and the reviewers also will express their good, this paper is very good, because they have done a huge number of measurements and the report is given average along with the error bar. So that is good. Okay. So that is just a suggestion for the people who are watching, like PhD students or some of the faculty from the private engineering colleges or small universities, including many big institutes also, people may be following, may not be following. This is a suggestion that I received from my supervisors and well-wishers who works in the similar lines. So I am just passing on, I am a mediator. Okay, I am just giving you what they have given me. I followed it, and the reviewers have appreciated that this work is rightly done and rightly measurements are taken and other things. Okay, so you can also explain how you are going to measure in the paper also. Okay. So abrasive particle acting mechanism in the abrasive flow finishing process, normally it will be axial direction. So it will be like a reciprocating motion, but in the centrifugal force assisted abrasive flow finishing process, there will be a rotation inside, and this throws the abrasive particles in the medium. The abrasive particle in the medium throws towards the active finishing region. Okay. The centrifugal force acts on the abrasive particle, and this force abrasive particle move towards the direction of normal to the axis of the workpiece. If you see here, this is the axis of centrifugal rod. This rod is given rotary motion, because of which what will happen, if there is a abrasive particle, once it hits, what will happen, this is because of the reciprocation and this is because of your centrifugal force, and resulting direction will be like this. Okay. The considered an abrasive particle with the mass m enters into the workpiece during the flow through the workpiece passage. Fa is the axial force, that is because of the medium reciprocation. I am explaining about the previous picture which you have seen. Fc is nothing but the centrifugal force due to circular motion caused by the rotation of centrifugal force assisted rod, which is normal to the flow of the medium, and Fa causes the abrasive particles to move in the axial direction. Va is also in the reciprocating direction. Fc will tend to push towards normal along with the viscoelastic nature also, because of which what will happen, the radial force that is going will be assisted by radial velocity also. Okay. You know, in abrasive flow finishing process, which is a conventional abrasive flow finishing process that I am talking, you have axial velocity, axial force, but indentation velocity is very less, that is why we always neglect, but indentation force will be there, that is called radial force. That means that you have two forces and one velocity in abrasive flow finishing process. In abrasive flow finishing process, you have axial force, radial force and axial velocity, but here your rotational speed also pushes the abrasive particle radially towards the axial motion. So that means that radial force is combination of your elastic component in the medium, at the same time combination of centrifugal force, and abrasive particle is going at a certain velocity. So you can also have centrifugal velocity instead of radial velocity. So the shape of the rod, you can see here everything is black, so don't worry. This is delta RA, small structures or delta RA, this is material removal. Okay. So among all these, if you see the triangular, spline, square and rectangular, so since we are talking about the finishing process, we talk about change in RA. That's why the change in RA is very good in terms of rectangular, because it is a finishing process. Okay. So the maximum improvement of the surface roughness is obtained in case of rectangular rod because of its unequal shapes, because in the square it is equal shapes. If it is triangular, there are only 3 edges are there. In a spline, normally it is considered to be the approximately circle, so the circular motion will be there. Here the author explained is that rectangle will have 2 different sides which are going to hit unequally. So the blending or the mixing of abrasives will be much better, and this will this enhanced. And if you want more details about why rectangular and other things, you can go through the paper where the authors are, you just type CFA AFM process, and you can cross check with Professor Ravindra Singh Walia or H.S. Shan and Pradeep Kumar, Professor Pradeep Kumar in fact. So you can cross check these papers, you will get much better idea about why rectangular. So people, you can do research in this direction also. So very limited work is done. So people, Professor Ravindra Singh Walia is continuously doing in this area, so you can contact him and you can get some of the ideas and you can improve the work also. So what are the thing about this particular slide is the best change in RA is in the rectangular surface. Okay, this is the cross. That means that since we are talking about the finishing process, we worried about what is the final surface roughness or whether how much finish is required. We don't bother about how much material removal is taken place. Okay, that's why the centrifugal force assisted finishing process, rectangular structure rod is good. Okay, the rod on the speed and extrusion pressure, if you see here, once the rod shape is fixed, the preliminary experimentation is done and the author finalized that rectangular surface, rectangular shape is giving better results. That's why the researcher done that particular preliminary work and now he is continuing with the rectangular rod. Okay. So you can see here the different extrusion pressures is changing, and one thing you have to understand, normally you can give bars also, and it is preferable to give megapascal, okay, in international standard and other things. Okay. The rotational speed, as the rotational speed increases, you can see here the rotational speed increases, what is happening is the centrifugal force will increase. The percentage improvement in surface roughness and the material removal increases with rotational speed. At higher rotational speed of the rod, greater centrifugal force acts on the abrasive medium and hence the abrasive particle impinge upon the surface and more number of peaks and more amount of the peak will be sheared. That means if my peak is like this, what will happen? If my force is less, what will happen? This much only removed. If force is more, this much will be removed. So the change in roughness will be more. So effect of number of cycles, if you increase the number of cycles, what will happen is the number of times the abrasive particle will contact the surface will increase, and what will happen? Your material removal will increase. At the same time, you can also see the RPM, rotational speed of the centrifugal rod also. If you increase the RPM, obviously as we have seen in the previous slide, the centrifugal force that is gained from the rod by the abrasive particle will enhance, and this abrasive particle go and hit with a greater centrifugal velocity and radial force, because of which what will happen, the material removal increases in this direction, and number of times, if the number of cycles are increasing, what will happen? Here also it will increase because number of times the abrasive particle hitting the or the shearing the workpiece will increases. The people also understood that is there any change in the metallurgical part of before and after, and there was XRD analysis is done and not much variation is there found, but from the XRD they have also understood that some of the residual stresses are generated, that is compressive residual stresses are generated, that is good for some of the applications. The authors from the XRD they have also analyzed the compressive residual stresses, and these compressive residual stresses induced into the workpiece after finishing will help in some of the applications. Okay. So, there is no change in the metallurgical structure and some other structure, but there is a induced compressive residual stresses which will help in some of the applications. Okay. These are the scanning electron microscopy images where you can see the surface morphology. Okay. Okay. So, this is initial surface, then the surfaces are there because of the centrifugal action, you can see random things are there. Okay. So, the advantage is surface finish is improving, but there is no perfect random direction. Okay. So, in the drill bit guided abrasive flow finishing process also we have seen, because you are having motion inside the medium slug or the medium, what will happen is you do not have control on the finishing region abrasive particle. Similarly, here also your centrifugal rod is rotated at the center, because of which the randomness is generated, but how much it has to go, that is not possible to understand. For that purpose, why I am explaining these two is that you come across another process called rotational abrasive flow finishing, that I have intimated you during drill bit guided abrasive flow finishing process, because if you can rotate the workpiece, your finishing region or active finishing region will be active. Okay. If you start rotating the medium, medium is a liquid type of medium or semi-solid type of medium, lot of losses will be there and abrasive particles are random. So, randomness is generated, and which may not give you a deterministic surface pattern on the workpiece. That is the drawback of drill bit guided process and centrifugal force assisted process. That is evident from this figure. Okay. You do not have proper direction of shearing. Similarly, in case of drill bit guided abrasive flow finishing also, that is why you need to go for the workpiece rotation, that we will see in the next class. So, from these two we can see the centrifugal force assisted provides the flexibility and better productivity, and this process does not affect the surface micro layer, that means metallurgical changes will not be there, and there is a slight increase in the micro hardness and residual stresses also will be generated, and this can be attributed to the work hardening of the workpiece and might occur because of the throw action of abrasive particle. Okay. This is about the two advancements, one is drill bit guided abrasive flow finishing process, another one is centrifugal force assisted abrasive flow finishing process. But both the processes have the drawback that assume that I want a certain pattern, like a honing process. I want a cross hatch pattern. Assume that this is my surface, I want a cross hatch pattern. Okay. I cannot get. Okay. So, how to get? So, these two processes are inside the medium, and the medium is completely random because your cutting edges are random, your distribution of abrasive particles are random, and it is a liquid nature. So, it is rotating. So, you do not have control at the away from the centrifugal rod, away from the drill bit, which is the finishing region. Finishing region is far away. Assume that this is my workpiece, my rod is here, this is my finishing region. So, it is far away. So, there will be a losses and other things will be there. Okay. That is the drawback of these two processes. Okay. We come across some of the advancements in the upcoming class. Thank you.